Okay, in parts C and D, we'll continue with 2007 BC Form B. And remember that we're given the differential equation dy dx is equal to 3x plus 2y plus 1. In part C, let y equal f of x be a particular solution to the differential equation with the initial condition 0, negative 2. Use Euler's method, starting at x equals 0 with a step size of 1/2 to approximate f of 1. Show the work that leads to your answer. So with Euler's, we have our starting x and y. We have our delta x. We have our y prime. We have y prime times delta x. And then we get our new x, which is x plus delta x, and our new y, which is y plus delta y. Now recall that Euler's is based on this simple idea that if dy dx times dx obviously is dy. What that's saying is that if you have this rate of change, dy dx is the small amount of change in y that's brought about by an infinitesimally small change in x. Well, when you multiply that by the change in x, you end up with just the change in y as opposed to the rate of change of y with respect to x. Well, we're not going to deal solely with d's, dy, dx. We're going to take the derivative, which is the rate of change, and multiply that by delta x, which is any change in x, and we're going to end up with a delta y, which is a change in y. So what we're going to do here is start with a point. We're going to use the derivative and the delta x to get a new y value along with its x plus delta x, new x value. And we're just going to continue to iterate that process as we go. So here we go. We have the original x value is 0, y value is negative 2, and we're starting at x equals 0, and we're given the step size of 1/2. So our y prime, or dy dx, which is based on 3x plus 2y plus 1, is 3 times 0 plus 2 times negative 2, which is negative 4, plus 1, which is negative 3. So the rate of change at x equals 0, y equals negative 2, is negative 3 units. Now we multiply that by the change in x, so we get our delta y, which is y prime times delta x, is negative 3/2. And we're ready to construct our new x value, which is x plus delta x, 1/2. Our new y value, which is y plus delta y, which is negative 2 minus 3/2, or negative 4/2 minus 3/2, which is negative 7/2. We're ready to begin the second iteration of this process. So the delta x remains constant. Now y prime, which is 3 times x, which is 3/2, 2 times y, which is 2 times negative 7/2, is negative 7. So we have 3/2 minus 7, and 7 would be 14/2. So we have 3/2 minus 14/2, or negative plus 1, which would be negative 9 halves. So we had 3 halves minus 14 halves, which is negative 11 halves, and then plus 1, which would be negative 9 halves. So our y prime is negative 9 halves. We're going to multiply that by the change in x, which is 1 half, and so we get negative 9 fourths. As our delta y, we construct our new x as 1 half plus delta x of 1 half gives us 1, and our new y was negative 7 halves minus 9 fourths, or negative 14 fourths minus 9 fourths, which is negative 23 fourths. And so our estimate using Euler's method for x equals 1 would be negative 23 fourths. And that does it for part C. For part D, let y equals g of x be another solution to the differential equation with the initial condition g of 0 equals k. So again, we're still working with our differential equation. dy dx is 3x plus 2y plus 1. Only here, we're dealing with x equals 0, y equals k. And we're going to start at 0 again. So x, y, delta x, y prime delta x, x plus delta x, and y plus delta y. We're starting at x equals 0 with a step size of 1 to approximate g of 1. So x equals 0, y equals k. Our delta x is 1. We're going to plug in 3 times 0 is 0. 2 times k is 2k plus 1. Multiplying that by the delta x, we still get 2k plus 1. Now our x plus delta x is 1, and our y plus delta y is k plus 2k plus 1, or 3k plus 1. Now we're told that Euler's method starting at x equals 0 with a step size of 1 gives the approximation of g of 1 is roughly equal to 0. So we know then that 3k plus 1 is roughly equal to 0. 3k would be roughly equal to negative 1, and k would be equal to negative 1/3. And so that does it for part D. We'll label these part C and part D, and that does it for 2007 BC number 5 from the Form B test.